This time, I have released an English tutorial code for fine-tuning a large language model, so-called LLM, utilizing the H2O LLM Studio code, and I would like to explain how to use it. One of the difficulties in performing fine-tuning is that you may not know what to do if you want to use the custom dataset. I hope that the series of information in this tutorial will be a starting point for beginning English-speaking AI students who want to develop your custom interactive AI to begin learning LLM by attempting conversational, chatbot-style fine-tuning with custom datasets and other methods. How to use Google Colaboratory. First, click on the Google Colaboratory sample code found in the video summary section and on the article page. To use this tutorial code, log in with your Google account. Click Copy to Drive or save a copy in Drive. Rename it to whatever you like, and then run the series of codes. To make it easier to see the changes in the answers after fine-tuning, let's first make inferences with the LLM before fine-tuning. In preparing the tutorial, I tried fine-tuning with the LLM base model, and could not see any changes with a free plan of Google Colaboratory. To infer with the LLM if Pythia 1.4b dedupe synthetic instruct, click on the tutorial code link here. To use this notebook, first save a copy to your drive and rename it. For reference, you can check out the current open source LLMs available on the Hugging Face website at this link. If you are interested what LLMs are trending when you have time, please check out the following. Execution Code 1 includes downloading the LLM published on Hugging Face. On the Hugging Face site, click here to copy the LLM name. Paste the LLM name here, and then run the code. After the download, etc., is complete, run the code too. Here, in the input prompt field, type in the question and then run the code. In this case, I will ask for the name of the YouTube channel that is creating this tutorial video. As a result, AI doesn't seem to answer well. Let's go back to the previous notebook and continue with the procedure. Let's begin the fine-tuning process. Tutorials teach specific knowledge to LLM. In this case, I will teach the YouTube channel where I am creating this tutorial video. There are a few preparations that we need to do before I can perform fine-tuning, so let's go over them together. In preparation 1, I will clone the H2O LLM Studio repository, the framework for fine-tuning LLM. To run the code, click on the triangle here. If you are on the free plan, you will not be able to run two notebooks at the same time, so on the screen that appears after clicking Manage Sessions, click Terminate Other Sessions at the bottom right of the window. After that, click on the Connect link here. Once the connection is made, run the code. Click on the file symbol to see the file on Google Colaboratory. In preparation 2, a dedicated virtual environment is created so that the H2O LLM Studio framework can be used. This one takes about 4 to 5 minutes to complete the program, so wait a while. In preparation 3, we downgrade the version of CUDA, NVIDIA's programming model for GPUs, because at the time of making the video, the framework did not seem to work as it is if we follow the official tutorial instructions. This also takes about 4 minutes for the program to complete, so wait a while. Now, let's try training on a custom dataset that you have prepared yourself. There is also a tutorial code for training with an existing dataset published on Hugging Face, which will be explained after the custom dataset edition. In the case of a self-made dataset, the procedure here is simple. After uploading the CSV format file created in the given format in the dataset folder, run the code in preparation 4. In the tutorial, I will use a dataset with several question formats arranged for the same answers to learn new specific knowledge. In this tutorial, I will fill in the questions at the instruction, as shown here. I will also fill in the answers at the output. I have made a template of the dataset available, so after downloading it at this link, unzip the compressed file. For Windows users, edit the file in Excel, and for Mac users, edit the file in the Numbers application. As an example, please make sure to export a CSV format file named dataset, using lowercase single bytes alphanumeric characters. For reference, let's look at how to edit and output the file in the Numbers application. First, edit the file. After editing, select CSV in the Export item in the File menu. Click Save. As an example, I will export under the name dataset. This time I will replace the template file. In addition, I have also made available the sample dataset used in this tutorial video. If necessary, I hope you can use them for the purpose of learning how to use them before you start fine-tuning in earnest. In this tutorial, I will use the sample dataset to explain the process. First, download the file at this link. Once downloaded, unzip the compressed file and rename it as a file name dataset. Then, upload the file to Google Colaboratory. The file will be placed in a dataset folder here. If necessary, click the refresh mark on the file. If it does not respond, close and open the file structure and see what happens. Next, enter the path to the dataset to be used in this case in this field of the executable code. The path to the relevant file can be copied by clicking on the dot mark on the far right. Then paste it. When you are ready, run the code. After executing the code, a CSV file called convert_dataset will be output here. If you would like to train on an existing dataset published on Hugging Face, please use the tutorial code at this link. Please follow the same procedure up to preparation 3 as you did for the custom dataset compatible version. For this tutorial, I will be utilizing this dataset with a quantity of 360. Copy and paste the name of the dataset here and run the code. The code here needs to be modified, and the data pre-processed according to the structure of the data set to be used. The idea of editing is that you can process the data so that the final data will be in two columns, instruction and output. For reference, let's look at the code here together. As a note on the processing, enter the split name shown on the Hugging Face here. To understand the process of processing the dataset, let's first display the results of the processing so far in the notebook. As an example, I will then rename the columns to instruction and output using the code here. The steps after this are the same as for the custom dataset edition, so I will explain them in the notebook for the custom dataset edit. In Preparation 5, run the mount so that it can be linked to Google Drive. After executing the code, you will be asked for permission, and you must authorize it with your Google account for Google Drive. After the permission is granted, the Google Drive folder will appear here. Preparation 6 specifies various parameters for performing fine-tuning. In this notebook, the GPU memory efficiency and optimization methods used during fine-tuning include quantization, gradient checkpointing, gradient accumulation, LoRa tuning, automatic mixed precision, etc., can be utilized. I have included a description of each parameter in the code, as far as we can tell, so please show code and fine-tune the settings as necessary. In the article page linked here, for your convenience in setting up fine-tuning, I have compiled the parameter information in an easy-to-read format. Please use this information when it is difficult to grasp the parameter information in the tutorial code. As a supplementary explanation, some of you may not know what the letter B means when looking at the LLM, currently available on Hugging Face. This one seems to represent how many parameters are in the model. The B stands for billions, and in the case of 1.4b, it seems to mean that there are 1.4 billion parameters. Up to the time of making the video, I have confirmed that Google Colaboratory's free plan, T4 GPU, can fine-tune a 3.6b, 3.6 billion parameter model. Fine-tuning seems to consume more memory in GPU as the number of parameters increases. Therefore, if you are running on the free plan, please try it once, and if it does not work, try again selecting a smaller number of parameters. Before executing the code, here is a minimal setup. In this field, specify the path to the folder containing the dataset files. In this case, the dataset is placed in a folder named Dataset. In this column, specify the path to the output destination of the fine-tuned train model. This time, I create a folder named LLM on the Google Drive, and inside that folder, I create a folder named My Fine Tuning LLM Demo. After fine-tuning, the training model and other data will be output in the folder, My Fine Tuning LLM Demo. In this column, specify the name of this fine-tuning according to your preference. In this column, copy and paste the model name of the LLM you are fine-tuning. In addition, specify the number of times to train at the epochs of the 5 train setting in the code. For example, an epochs equal to 1 means that the number of trains is 1. In the notebook for the custom dataset version, the default setting is epochs equal 50. Also, in the notebook for the public dataset compatible version of Hugging Face, the initial setting is epochs equal 1. Once the settings are made, run code. Preparation 7 is a program to reflect the fine-tuning settings specified earlier in the file. Thank you for your patience. It has been a long time in advance preparation, but now it is time for fine-tuning. Here is a summary of the LLM model name I used for fine-tuning, the name of the dataset, and the time it took for fine-tuning. Although this is as much information as I had tried by the time the video was created. As I tried, it seemed that the larger the dataset, the longer it took to train each time. Listed at the bottom is the situation when setting up this video tutorial. Note that the training time, etc., seemed to change each time the program was run, so I hope you can use this as a reference only. Now let's run fine-tuning. The first time you run it, it will take some time to download the specified LLM. Fine-tuning also takes time, so wait a while. It is done. To see the results, compare the initial train loss and validation loss values with the final train loss and validation loss values, and check if the values are close to 0. As far as I have tried, it seems that the closer the number is to 0, the better the response tends to be for inference. In addition, I also look at the change in train loss and validation loss values for each number of training sessions, and check if the values increase during the course of the training. If necessary, I adjust the number of training sessions to achieve a training model in which the values of train loss and validation loss are close to zero. As a supplementary explanation, there is also a setting to save the best result during training within the code for specifying the fine-tuning parameters in preparation 6. Specifically, in the code, set this save best checkpoint in the 5 train setting to true. Then, let's also look at the results output to Google Drive. The data is output in this folder. You can see the training logs, the results of validation, and the training model. When the same settings were run many times, the results of the last run seem to be updated in the folder. If necessary, you can download the data to your own computer. One thing to note when downloading is that the learning model called checkpoint, PTH, is downloaded separately and renamed, so be careful not to miss it when managing it. Once the download is complete, unzip the downloaded file and place the learning model as well, if necessary. Since the trained model is large, it may be easier to avoid errors due to insufficient space by deleting the trained model in the Google Drive to free up more space, if necessary. In this case, I will restore it as it will be used later. Now let's take a look at the results of this fine-tuning. As described in the instructions here, run the code by specifying the path to the folder where the fine-tuning results are output to Google Drive, with one space next to the letter E. The Google Drive path can be copied by following the steps performed in the video. After copying the path, paste it here. Type your question here in the space provided. As far as we tried, it seemed to respond to the Enter key in the middle of character conversion. So it may be a good idea to create the question in advance, copy and paste it, and then press the Enter key. Now, let's try the learned question text. That's good. Let's try the other learned questions. As far as I tried, I got the impression that if train loss or validation loss is close to 1, it is easy to give wrong answers. Although it depends on the LLM used, in the case of the LLM I used this time, fine-tuning the question format with more rows in the dataset seemed to improve the accuracy. Depending on the LLM used, in the case of the LLM I used this time, the accuracy seemed to be improved by fine-tuning the question format with more rows in the dataset for wrong answers. With the range of information I have tested in the Japanese LLM, I have also experienced that training one question format is enough to handle a variety of question formats. To exit, type exit and press enter. Since I am Japanese, I am still not very good at making tutorial video in English, but thank you for watching this video to the end. Right after I created the tutorial code for this English version of LLM Fine Tuning, I was not sure what to do because I could not get them to learn it well using only the free Google Colaboratory plan. In the end, I found that having AI learn a variety of question formats to teach a single piece of knowledge improves accuracy, and I'm happy to release the tutorial video. I believe that LLM is still in uncharted territory in this day and age. Capital I. Believe that LLM is still in uncharted territory in this day and age. I hope that the series of tutorials I have created this time will be an opportunity for beginning AI students in English speaking countries who would like to start learning about LLM to begin to experience the profound world of LLM by starting out with LLM fine tuning. See you soon.